Going on now to topic 1 of chapter 4, Inequalities and Applications. Now in chapter 4, we are only doing this section. And what I will do is take 2 days of class time to go over it because there's lots of stuff here. And we will have a test on only this one section. So your homework, which is basically your practice and quiz me's, are going to be very important. So some of these are familiar from the past, solutions of inequalities, where inequalities had these signs. Let me just review them with you. This was greater than, less than, greater than or equal to, less than, let's get the right one there, less than or equal to. Now we're also going to look at interval notation again, where while we're here, the signs for that were greater than was a parenthesis facing to the right. Less than was a parenthesis facing to the left. Greater than or equal to was a bracket facing to the right. And less than or equal to was a bracket facing to the left. Now we had done all of this on earlier videos, but this is just a review. And remember, the parentheses means the number isn't included in the set. The bracket indicates the number is included in the set. And as a little review too, that for these first two up here, when we used to graph numbers in high school, like say this was a 5, then we'd have a hollow over the 5, that it would sort of start but didn't include at 5. And then if it was less, it would be this way, greater this way. But then if we darken that, we would say 5 is included. So that would be these two where we use a bracket. So the hollow would be the parenthesis, the solid dot would be the bracket. Okay, so we'll give you some time to take a look at 1 through 4. You can pause the tape. So going over these then, for the inequality, typical inequality, open interval, it's where we have parentheses on both sides. Again, that indicates these are in interval notation that the -4 and the 0 are not in the set, but what is between them. And B would be the closed interval, where we use brackets, here indicating the 1 is in the set, the 10 is in the set, and everything in between. And then half open, again, makes sense. We have 1 with a parenthesis, one side with a bracket. So -6 is not included, but 2 is included in the sets. Now in number 5 and 6, they're asking to determine if we substitute these for our value y, is this going to be a true or false statement? Will it be a solution? Well, we just put the 5 there. So 2 times 5 is 10. 10 minus 1 is 9. Is that greater or equal to 7? And the answer is yes. If we put a 4 there, 2 times 4, 8 minus 1 is 7. Is 7 greater or equal to 7? And that is yes, that's true. But if we put any smaller numbers in there, like 0, this then becomes a -1. Is that greater or equal to 7? No. And also a -2. And the same thing applies here. You're just substituting this value into y and then seeing if it's true. So let's take a look at the first one. So that would be a -3 times 3 is -9 plus 1. And then here there's another y on the other side. So I'm going to tell you a little strategy here to make this a little easier. I should have picked up on this earlier. You see this -y over here? That's going to confuse it. So solve by adding a y here, makes this 0. So this then becomes 4y plus 1 is less than 8. So that would be the strategy I'd recommend. So -3 times 4y, or 4 times -3 is -12. Plus 1, is that less than 8 now? We don't have to worry about this anymore. And the answer is yes. Now if we put a +3 there, that makes this a +12 plus 1, that's 13. That's not true. And if we put a 2 in there, that's not true. And if we put a 0 in there, plus 1 is less than 8. So that checks out. Now, we've done some like this before. Graph each inequality and write the solution set using set builder and interval notation. So we're going to do all three. First, we're going to graph. Well, where is -3? That's the number we're interested in. 1, 2, 3, right here. -3. And what's this sign? X is less than or equal. Now, do we choose a parenthesis or a bracket? And the answer is a bracket. And we darken this and put our arrow. So there's the graph. Now, interval notation will be from -infinity, that's where this is coming from, out here, up to a -3, and we just take it right from the graph. And there's our interval notation. Now, set builder notation, we just put a line here, another X, and now use braces. Okay, we've done that before. So here we're interested in a 2. Are we going to use a parenthesis or a bracket? Well, it's only greater than, so we're going to use the parenthesis. Darken it. Now for interval notation, it's going to be parenthesis 2, comma, infinity. Remember, infinity always has a parenthesis. And for set builder notation, we just add a Y and brace. Now in these next three, we want to solve inequalities. So we're just going to transpose that, and that then becomes t is less than or equal to -2. Because when we transpose that, that came as a -7 there. Now to graph, our -2 is right there. And we're going to use a bracket. It's got to go right there though. And darken this side. To use set builder notation, we just put a T there and interval notation that's coming from negative infinity up to -2 bracket. Now here we transpose that, and we get y is less than, this is going to be a positive 13. Well, when they give you a graph like this, and there's not enough numbers for 13, just make this 13 right there. Change that. That's 13. So, are we going to use a parenthesis or a bracket? Parenthesis, and it says y is less, so our parenthesis will face to the left. Darken it. There's our graph. Set builder at a y. And interval notation, it's coming from negative infinity up to 13. 13 is not included in the set, so we have a parenthesis. Okay, for number 11, here we're just going to divide both sides by 0.4. And as we do our calculation, this is going to be a negative. Let me write it out here. X is greater than a negative 7.5. So we just put a negative 7.5 on our graph. And what do we use here? A parenthesis or a bracket? Well, in this case, it's going to be a parenthesis facing to the right because it's x is greater. There's our graph. Set builder notation, we just add an x and a braces. And for interval notation, again, parenthesis, negative 7.5, comma, positive infinity. All right, in number 12, we're going to use a technique to get rid of fractions. Now, a very interesting thing is going to happen here. Watch this. We're going to multiply both sides by a -3. Now, in order to keep this statement true, when we multiply by a negative, we're going to have to reverse the direction of our inequality sign. So now the -3's cancel out, and we get 2m minus 5, and this will be a -3 there. The difference, we got rid of the fractions, but we had to multiply by a negative. When we do that, we have to change the direction, a very important thing to keep it true. So we're just going to transpose. So we get 2m is less than or equal to, the -5 on this side becomes a +5. So this will be 2. So m is less than or equal to 1. So we can put that here. There's our 1. And we're going to use a bracket. It's going to face to the left. Interval notation is coming from negative infinity up to 1. 1 is a member of the set, and here we're just going to put another m, brace there, and a brace there. Now for number 13 and 14, they're introducing function values, which is okay. And trying to understand it, of course, is the next step. Well, here they're saying this is the function of x and this is the function of g here. And now they're saying the function of x, which will be 3x minus 1, that's our f, is less than or equal to this g, which is x plus 5. So we're just going to solve that. That's 2x. This becomes 6. Going to divide by 2. X is less than or equal to 3. So there's our 3 right there. We're going to use a bracket. And interval notation, this is coming from negative infinity up to 3. 3 is included in the set, and here we just put another x and braces. The key to this is here, there's the x, which is this. There's the g, which is this. And we just put our inequality sign between them. And it's the same thing here. There's f of x. 5 minus 2x is going to be greater than, and there's what g is. 6 minus 7x. Now remember, if we can just add things, we don't have to change the direction of the inequality. So I'm going to add 7x to both sides. This gives me a 5x here, and I can keep my inequality sign that way. And here we're going to subtract 5 from both sides, and this gives me a 1. So I now have x, writing on it, we're going to make it a little bigger, x is greater than 1/5. And there I finished it up a little bit for you. We have here that an interval notation, and there's our graph, and there is, well, that was set builder notation, excuse me. This is our interval notation. As we look at number 17, it's exactly the same. It'll be this is less than that, and we've done some like that. Same thing here. This is less than or equal to that, and solve it. Again, I don't want to make the tape too long, so let's go on, where they're asking us to write the solution using both set builder and interval notation. Here they're not asking us to graph it. And I'm going to do the first two. The other ones are similar with fractions. Again, some of this gets difficult. We're going to tend to keep it more toward the easy ones, the ones that I'm illustrating. So, as we continue, we see we have the distributed this, and I'm trying to keep my variable positive so that when I divided by 4 here, I didn't have to reverse the sign. So to put this in set builder notation, we just add an x, braces, interval notation, this will be a bracket, x is greater than 7, infinity, and like so. And these are the others, and they're done in a similar way. Again, they get a little tedious, and we're getting some fractions here. Up to 18 is probably the difficulty that we might have on a test. And again, you want to master, ask questions as needed. All right, and as we get ready for applications, we're going to be converting English into algebra. A number is at least Well, this is the phrase for the symbol at least greater than or equal to 15. Here the times of the race were between 35 and 50 minutes. So here's a compound inequality where the time is in the middle, and it would be greater than 35 and less than 50. That's how you would write it. All right, let's go on to work some problems. Okay, here's some word problems. Again, you'll have to read it carefully, but in essence, it's a studio can rent a truck for either $60 with unlimited mileage or $45 for 30 cents per mile. Which would be the better deal? So we set it up as sort of an equation, but an inequality. 30 cents a mile plus $45 is going to be less than or equal to 60. Well, we subtract 45 from both sides, get 15. And then we're going to divide both sides by 0.30. And we get m is less than or equal to 50. So if you plan to go less than 50 miles, or up to 50 miles, then this would be the better deal. But if you plan to go more than 50 miles, paying the $60 would be the better deal. Going on to example 24. Here a portrait studio is offering $100 sitting fee plus $30 an hour for off-site photography, or $50 an hour for off-site photography. Which is the better deal, and where does it become better? Well, it's $30 an hour plus $100 as compared to $50 an hour. Well, you solve it for this by subtracting 30h from both sides. You get 20h equals or is greater or equal to that. You get this, h is greater than or equal to 5. So what does that mean? Well, if you're going to be less than 5 hours, then this one's the better deal. If you're going to be more than 5 hours, then this is the better deal. Okay? If you recall, I said I had to sometimes take paper and pencil, and this is sort of an interesting one here. Here, this gal, Kamala, can be paid a salary of $800 per month plus 8% commission on her gross sales. Or she can just take $25,000 or $2,500 per month with no commissions. So what would be the better deal for her? Well, this is one side, 8% of her sales plus this. When will that be less or equal to that? So if her sales are going to be greater than this, 21,250, then plan A is better for her. But if she's not anticipating this much sales, then plan B would be the better one. Now, reading this through, a little confusing, and I guess some auto rental places do it like this. If you pay for the full tank of gas, which would be $3.79 per gallon, then you don't have to worry about filling it up the tank. Or you can just pay for the gas that you use, but to fill it up when you get back costs you $7.15. That's like the price in Europe, actually. So when is it a better deal? Well, Again, your tank holds 18 gallons, and if you fill it up at this price, that's what it would cost to fill up the tank. And you're wondering how many gallons. So at 7.15 or $7.15 a gallon, when will it be the better deal? Well, you just divide both sides here by 7.15, and it's a better deal if you're going to use less than 9.5 gallons approximately. If you're going to use more than 9.5 gallons, it's cheaper to actually pay for the full tank of gas. Okay, that'll wrap this up. Again, some of these are just brain teasers to get you to think about things and to use what we've been working on.